Hello everyone. Today we are going to write MATLAB code for trapezoidal rule. So this is the relation for finding the area by using trapezoidal rule. So firstly we will discuss its analytical approach. Then we will construct flowchart, and then after that we'll write the MATLAB code for trapezoidal method. So let's take an example. So here we need to solve this integration, okay, and this is the integration with upper limit 6 and the lower limit is 0, and this is the equation function f of x is given as a 1 upon 1 plus x square. So by using trapezoidal rule, we need to find this integration, and here number of streets we have to consider as a 4. So here firstly we will write initial limit, okay. So x0 is 0 in our case and xn is 6 and number of strips are given as a 4. So from this we can find the step size. So for step size we have the relation x10 minus x0 upon number of strips. So 6 minus 0 upon 4 is equal to 1.5. So in this case step size is the 1.5. Now so we will find the value of this function, okay, for each value of x, okay. So when, so start with the lower limit. So lower limit value of x is 0, okay. So for that we'll find the value of function. So when x is equal to 0, that time y is equal to 1, okay. So just substitute value of x in the equation. So 1 upon 1 plus 0 square, so it gives you 1. Same way, now consider the next step size, okay. So 0 plus 1.5, so it gives you x1, okay. So just substitute this 1.5 in this equation, so you'll get 1 upon 1 plus 1.5 square. So x1, when x1 is equal to 1.5, that time the value of function is a 0.3076. Okay. Now again add a step size, so that in the next iteration you will get x2 is equal to 3. So when x2 is equal to 3, that time value of function is a 0.1. Okay. Then same way, when x3 is equal to 4.5, that time value of function y3 is 0.047, and for upper limit, when x4 is equal to 6, the value of function is 0.0270. Now use the trapezoidal rule. So trapezoidal rule is, so what is the, so here this is the relation, okay. So by trapezoidal rule we can find the numerical integration with this relation. So h by 2, here h by 2 means your step size. So step size divided by 2, and in the bracket you need to write y0 plus yn. So y0 means your the value of function for lower limit, and this is the value of function for upper limit. Then plus 2 into all remaining terms, okay. So in this our case remaining terms are y1, y2, y3. So just substitute this value, okay. So here y0 is 1, okay. Y4 means last is a 0.027, okay. So just write here. Then 2 into, then remaining terms are y1, y2, y3. So write this value of y1, then y2, and then y3, okay. Just do the calculation and you will get the area as a 1.4521. So this is the integration value by the trapezoidal rule. So this is a new analytical approach for this trapezoidal method. Now we will construct the flow chart for this trapezoidal method, okay. So first you need to start, then whatever the function is there, y is equal to f of x, that you can define. Then give the input data. So we have the input data as a, yes, lower limit, upper limit, and number of strips. The once you have this input data, you can find the step size, okay, by this relation xn minus x0 upon number of strips. Now initially we will take one variable as a sum, okay, and we, for this we will take the value as a 0. Now we will consider the looping. So here we will take the for loop, okay, and for in for loop we are going to write this logic I is equal to 1 s to n minus 1. So when this logic is true, so we can write that sum is equal to sum plus f of x0 plus I into h, okay. So sum initially here 0, 0 plus f of x 0 plus I h. So when I is equal to 1, so we will write as a f of x 0 plus h. When I is equal to 2, we can write x 0 plus 2h. When I is equal to 3, we can write f of x 0 plus 3h. Okay, and the purpose of this loop is to just get the value. Okay, so from this we will get these values of function. Okay, y1, y2, y3. So when I is equal to 1, so that time we are making x0 plus ih. So h is in this case is 1.5, so 0 plus 1.5 will give x1. Okay, and when we are putting this x1 value in the function 1 plus 1 upon x square, you will get this corresponding value of y1. When I is equal to 2, so that time we can say that we will get the x0 plus I into h means 2 times h. So h is 1.5. So 2 times h means 3. So 0 plus 3 is 3. So you will get x2, and when we are substituting this x2 value in the function, so you will get y2 as a 0.1. Next, in the next iteration, x3 becomes 4.5, and for that we are getting y3 as a 0.047. In the next iteration, last iteration, when x4 is equal to 6, that time you are getting function value, okay, as a 0.0247. So here the purpose of this loop is to just get the value of the function, okay, for every step size. So for first step size we will get the y1, for second we will get y2, for third we will get y3, so on. Now just look at this formula. Okay, so in the formula, uh, for this y1, y2, y3, we need to multiply by 2. So here we will multiply this sum variable by 2. Okay, so we will get 2 times y1 plus y2 plus y3. Then we are taking one more variable abc. Okay, so purpose of this abc variable is just to get the value of function when x is equal to 0, and value of function when x is equal to n. So in short, this logic gives us the value of addition of y0 plus yn. Okay, so then we need to find the total area of. Okay, so you can find the total area by taking the formula as h by 2 into sum. Okay, sum means 2 times y1 into y1 plus y2 plus y3, and abc means y0 plus yn. Okay, so f of x0 means, in short, we can say that it is the y0, and f of xn means we can say that it is the yn. So this is the required formula, h by 2 into y0 plus yn into 2 into y1 plus y2 plus y3, and at this area you can print, okay, and make the end statement. So this is the flow chart. Now using this flow chart we can write the code. Okay, so here code is written. Okay, so what I'll do, I'll copy this code, okay, and I'll paste in the print. So here, so this f is equal to in line. Okay, so the purpose of this line to just input the function. Okay, we can input function. So in MATLAB, to give the function or to write the function, inline command is there. Okay, so by using inline command we can enter the function. Then this x0 and xn are the upper and lower limit of the integration. Then n is nothing but your number of strips. Okay, from that you can find this h means, in this case, it is a step size. Okay, so here I'll write as a step size. Then here this loop is used. Okay, and the purpose of this loop is to get, the purpose is to get value of function. Okay, now what is the value of function? We will say that it is in terms of y. Okay, so it may be y1, y2, y3 in our example. Okay, so the purpose of this loop is to get the value of function y1, y2, y3 when x is incremented incremented by I into h. Okay, so initially when we will take x0 means your initial limit, okay, lower limit plus step size. For a second iteration, x0 plus 2 times h, then x0 plus 3 times h, so that you will get x1, x2, x3. Okay, and correspondingly you will get the value of y1, y2, y3. Okay, so just here you will get the sum. Okay, then you apply your formula. So the formula is area into h by 2 into f of x0 plus f of x1. So f of x0 means y0 value, f of x1 means yn, plus 2 times sum. So here in sum we'll get y1, y2, y3. Okay, so this sum gives you, okay, so 2 times sum means here you can write, so 2 times sum. Okay, so sum means here it gives you 2 times addition of y1, y2 and y3. Okay, so your, this is the your required formula. Okay, and after in calculation you will get the value of area. Okay, that is nothing but your integration value, and you can print this area. Okay, so this is the MATLAB code. Okay, now I'll show you how to execute this code. So just copy this code, okay, and you can run this code in MATLAB software. Okay, or again there is some online tool as a Octave online solver. Okay, so here you need to just create file. Okay, so you can write as a trapezoidal rule. Okay, okay, just refresh it. So just make one more file as a trapezoidal rule, and just select this trapezoidal rule. Okay, and here paste your code. Okay, then save it. Okay, and execute the code. Okay, so it is asking me the lower limit. Okay, so here lower limit is a 0. It is asking me the upper limit. So in this case upper limit is the 6. Then it is asking me the number of strips, so you can enter the number of strips as a 4. So this is your required answer. Area is equal to 1.452397. So you can cross check this answer with your analytical approach. Okay, so this is 1.4521. So answer matches means our code is correct. Okay, then same answer you can find by using solver. Okay, so solver are just you need to enter this value function at the rate. Okay, and you need to enter your function. So now function is in terms of x, and here you can write the function. Okay, so what is your function in this case? So this function, just copy this function. Okay, and you need to enter this function here. Okay, so 1 upon 1 plus x square, and here in this function you need to just into quad, and here you need to write upper limit and lower limit. So here your lower limit, and here upper limit is the 6, so you can enter here 6. Okay, so when you execute this code you will get the final answer. So this is about trapezoidal rule.